Hello, welcome to this video. In this video we are going to discuss about the advantage, disadvantage and the modeling styles used in Verilog, and then we will discuss about the OR gate program, how to create by two modeling styles. So first of all, I want to show you the advantages. So advantages of Verilog has a maximum program. Keywords of this Verilog is related to C programming, and the operators are also related to almost similar to C programming. And the Verilog programming also has high speed of operation because multiple lines that we write are executed simultaneously. So at same time the compiler executes and the interpreter interprets multiple lines together. So that is the simultaneous execution process. And for the disadvantage, the Verilog program is case sensitive. So and the another one is it is vendor specific, because as of now the MODELSIM is already bought by our Siemens. So it is now a Siemens product, and it is vendor specific and proprietary. So that's why we are using the FPGA, Intel's FPGA MODELSIM. So it's not any crack version or anything. It's just a free version which does not need any license, and it's better for our students to learn. So now we will discuss about the four modeling styles which are present in Verilog programming. So modeling means how to write the programs. So you can write program in very different ways also. So one person can do a program in one way, and another person can do the same program, the same output in different ways. So there are four modeling styles. One is data flow, another one is behavioral, and third one is structural, whether the last one but not the least, it is the mixed type modeling style. So basically these four modeling style will be discussed thoroughly by each and every video which are upcoming in this channel under my Verilog playlist. So now let's begin the programming for the OR gate. So OR gate, I am going to open my MODELSIM software. This I have already shown you how to install that in the previous video and how to open that. So I am going to open this MODELSIM software. So as you know, the software is little bit heavier, so it will take each and every step to be completed with a particular time. Okay, so please be patient when you are using this software. Now as you can see, it has opened and it is showing us this jump start option. So I am going to jump start, and instead of creating a project, I have already created a project, so I can open that project also, but I can go for a new project also. So those who have not created any project, so you can create a project, or those who have already created a project, so they can open a project. So I have created already one project, so this is the project 1, and I am going to browse it. So it is already by default browsed. So if not, you can go to browse, and then by the explorer you can select anything. So just like you can go to this PC, then C drive, then from this one I can select there are many things. So let's say project 1.mpf. so I can select this and say open and say okay. Yeah, so this is the project which I have already created. So in this I have already created the file for ease of time, so that I can focus that in the explanation more than the typing. Okay, so I am opening the OR gate behavioral. So I am starting with the behavioral programming first, because the data flow is very easy, and data flow I will create the data flow here, I will type it here, but the behavioral you need to understand the behavioral. So first of all, the behavioral, it is like one black box. So what is a black box? So I am using the paint to make it more easy to understand. So I have opened the pen and paint under. So this is a black box and it will have some inputs. Let it be what it is. It will output. So why 2 input? As I have taken OR gate for example, so it will have 2 inputs, A, B, and the output will be Y. So this is what the function of OR gate. And for the clear view, I want to show you that A, B, Y. So those who don't know what will be the truth table for OR gate, please remember it, because we all have already studied in our earlier days. So for 0 1 it will be 1, for 1 0 it will be again 1, for 1 1 it will be 1. So by this truth table you can see that this black box output will be varied by this formation. Okay, so we have to create this black box, and this black box contains the behavioral code. So behavioral actually basically gives an idea about a black box. So the black box is named as on_behv. So I am giving its name. Okay, so it was written in small. I am mentioning again that the one and only disadvantage and the most common disadvantage of this language is it is case sensitive. So this is or_behv. So this is the black box name, and it has 2 inputs, A and B, and 1 output, Y. So I have written it here. So this is input A comma B and output REGY. So why REG? REG is the register, it is register type. So the output Y is register type. So you have to mention that the output is register type, and every time the output must be register type when you are writing program in behavioral modeling, else the compiler cannot understand that whether it is in data flow or in behavioral, and it will produce you error each and every time. So please make sure you have used the REG before the output register, the output port. Yeah, now I will discuss you the second line. So second line, it is always @A comma B. So this means always @A comma B means always when I start the simulation, it will try to find inputs A and B. So if it is finding no input, either B is missing or A is missing, so it will generate a simulation error. So basically this is the main purpose of writing this second line. And the third line is begin. So I am beginning something. What I am going to begin? I am going to begin one control statement, that is if and else. So if A equals to 0 and B equals to 0, so this is an and, this is an logical AND operation. Those who have gone through our previous videos under C programming playlist, so there you can find that I have discussed that this double ampersand sign means a logical AND. So when it is satisfied, it will give the output as y equal to 0, and else y equal to will be, every time the y will be 1. And this end is referred to the begin. So here I use begin, here I need to end the begin. Okay, and this end module is final statement to end the total module. And after writing that, you have to save that. So to save this, you have to Control S, and it is saved. Now you have to go to this one, this or_get.behave.v. So you have to go to compile, and compile selected. So you can see compile of this file was successful. So it is great news for us that we have written it without any error. So if you are getting any error, please check whether you have written this @ or not, whether you have mentioned this reg or not, whether you are mentioning all the semicolons where it is necessary. You must have to know where it is necessary. So after the module statement it is necessary, the semicolon is necessary, but for not for always, not for begin, not for end, or not for end module, but it is necessary after the if, after the else also. So please check whether these three are given or not, and your program is similar to this one. So after compiling this, I am going to start simulation. So how to go? So I have shown you in the previous also, I am again repeating. Go to this library, this one, so beside your project window, and here you can go for work, and then you can go for this or_behb. So this is the or_behb, that is the module name. So I am repeating once. So under the project or_get_behv.v, this is the file name, but the module name is or_behv. That's why under the library, under the work, I am getting or_behv as my module. So I can right click it and click simulate, or I can double click it also. So as you can see, this is the window after the simulation is successfully completed. So now you can see there are objects. Objects means the inputs and outputs. So and there are waveform also. So if you are not getting the wave here, so you can go to the view and you can click the wave. So you will get the wave panel just right side of your hand. So this is the wave panel. Now you need to add all the input and output parameters to this wave panel. So I am right clicking on this objects panel and I can click add to wave signals in region. So please follow this step to add your parameters. Okay, so this is the parameters I have entered. Now I am going to select the clock. So right clicking on each and every one, and clock, let it be 100, and let it be first edge to be falling, and next OK. Now go to a clock, let it be 200, falling, OK. Now go to this run time. So this one, this is the run length, so I can say is 1000 ns or 1 ms also, so it is same. So I am going to click this run button. This is the run button, right side of this run length. Yeah, so you can see that this is the output waveform, but how to see, how to be sure that it is the, correct as we want the output from the black box. So because by clicking on this, you can see that this is 0, this is 1, and the output is 1. Now this is 1, this is 0, the output is 1. This is 1, this is 1, the output is 1. But when these two are 0, the output is 0. So this is what we exactly wanted from this black box. So our program under this or_behv module is perfect, and the simulation is also saying that. So congratulations, you have successfully run and simulated and even analyzed your first behavioral program. So congratulations everybody. Now I would like to show you the same thing in a different modeling style, that is data flow. So I am just crossing this, so please cross this. Now go to simulation and end simulation. Are you sure you want to quit simulating? Yes. So I have left my simulation panel. Okay, so give it some time to be reset. Yeah, so it is now okay. And again I am saying please keep patience. So go to this project window and now right click here and add to project, new file. And now I will write here or get data flow. VHDL, so change it to Verilog, say OK. Now double click on this. Okay, so you can double click on this, or also right clicking you can say edit, so all are possible. So now you have to write it in your data flow modeling style. So I will write module or data flow. In the input we will get A and B, in the output we will get Y. Now let's say I want to assign, so assign is related to data flow modeling style, so assign Y equals to A and then logical OR, that is a pipeline character just upward of your enter key. Just see the up key, upward key located just in your upward of the enter key. So the key is pipeline character, so one is slash and another is pipeline. For this pipeline you have to shift and click that button. So please follow in your keyboard, focus in your keyboard. If you are unable to find the pipeline character, please focus on your enter key and see that in the up of your enter key there is the pipeline character. So this is the A pipeline B, so this is logical OR. Now enter and let's say in module. So it's so simple. Now save it by Ctrl S and right click on this and compile selected. So here you can see again compile or get data flow.v was successful. So you have successfully compiled this. Now it's time for run this, it's time for simulate it. So to simulate it, again go to the library, then under work. So if you find this type of work, so please click on the plus sign and you have to right click here on the or underscore df, okay, and simulate. So as you can see the simulation panel is present here, and please give it some time. Yes, sorry. So many times many can find some problem that when he or she is clicking the simulating button, so he or she cannot find this object section, this object panel. So again go to this view. So view is very much important here, okay. So here you can find the object, so it is not ticked, so you have to tick it, so you have to click it and you can get the object now, okay. So don't worry, every problem has its solution. So just right click on these objects and go to add to wave and signals in region. But before that I have forgotten. Have you forgotten? You should not forget. So you must have to go to view again and then you have to add wave also. So when I am clicking this wave, again the whole panel will be set to this side, and next you go to this right and add to wave and then signals in region. Now put this A and the clock is, let's say, 200 and the age is falling, first age falling, okay. B, the clock will be 100, the first age falling, okay. And the runtime will be for 1000 ns. So I am getting this run button and this is the output. So is the output same as the previous one? Yeah, right, yeah. So it is the same as the previous one. So this is how we can find our waveform. We can simulate our program and we can see the waveform, the digital waveform by the Verilog program. So I have covered here only two modeling style. One is your data flow, another one is your behavioral, but there are two also remaining, structural and mixed. So these two we will cover later in the upcoming videos. The video of today is almost going to be 20 minutes. so that's why I don't want to show it here. And for the structural we need some more complex circuits. So for normal basic gates it's not good to use structural or mixed anything. So that's why we can go for other modules where you can see how to model your program by structural method or by mixed modeling style. So for this video it's enough, and I think I have cleared what is the behavioral program and what is the data flow. So basically if you see the data flow is almost same like the C programming. So data flow is, that's why I said in the early that the data flow is too much easy to understand, so it does not take any problem. So you have to think one thing, that the output is Y for data flow. For the behavioral the output will be REGY. So REG here and then space for the behavioral. Okay, so this will be for behavioral style, where the output must be register type, else it will create problem. So thanks for visiting this video. If you have any query or any doubt or any suggestion for me, please make a comment under this video and stay with our channel. If you are new to our channel, please subscribe our channel to get notification. Thank you.